And as you go down, then you have the brain tissue, brain parenchyma, and inside here is a brain. And there have been two guys that have been working on brain, and one of them is called Monroe, and the other one is called Kelly. These two guys says that the brain volume, or the brain that is engulfed inside, its volume remains constant. Any change, and the contents of the brain include cerebral blood vessels, and you have the brain tissue, and you have the spinal fluid, cerebral spinal fluid. The function of cerebral spinal fluid is very important. It protects the nerve tissue and it feeds the nerve tissue. And there is inside there arterioles, and you have the brain tissue. These three, according to Monroe, says the volume of the things inside must remain constant. Any change in one of these must be followed with a decrease in the volume of one of the two other three. So when you decrease the CSF, for example, when you increase the CSF, you have to decrease the cerebral blood flow or decrease the brain parenchyma, because you say any increase in one of the things must be followed with a proportional decrease of the other two. And when the brain tumor increases the brain parenchyma, you need to decrease the other two. So how do we keep these things constant? Well, according to Monroe, there is the blood-brain barrier, meaning the cells inside the brain. I mean, endothelium. Supposing this is the endothelium, the cells here have very tight junctions, and they will not allow the entrance of macromolecules. Only small molecules are allowed to enter the brain cells. Supposing this is the epithelium of the cerebral blood vessels, you have the nerves endings that regulate the size of the lumen, capillary lumen. So this innervation controls the caliber, the diameter of cerebral arteries. So the blood-brain barrier is important because in the management of diseases like tumor, you need to choose your drug very accurately, because the blood-brain barrier will not allow the entrance of the other molecules. So, because of this, cerebral blood flow is maintained constant. So, according to Monroe and Kelly doctrine, it says cerebral blood perfusion equals mean arterial blood pressure minus intracranial pressure. Cerebral blood perfusion equals mean arterial blood pressure minus ICP. Supposing the ICP is 15 and the map is 140 millimeters of mercury, the CPP, cerebral blood perfusion, would equal to 140 minus 15. So what you will have is equivalent to cerebral blood flow, which is very important. So why should we maintain cerebral blood flow constant? It is because if we don't do that, the intracranial pressure will rise. So how do we measure cerebral blood perfusion? We measure this with the principle that says the quantity of amount of a substance injected in the body is divided by arterial ventricular differences multiplied by 1. That is how you calculate the cerebral blood perfusion. So that is what they call autoregulation. It means the blood pressure, the blood vessels in the brain must constrict or dilate in order to maintain the map. Otherwise, you will end up with high intracranial pressure. And that is what I'm going to share with you today. Thank you very much.